Hello, IPXers. Welcome to the world famous studios. I don't know why I say that, but I do. And today we're going to be talking to Muhammad from NovelBits. Now, he's going to tell us everything about what he's doing in Bluetooth. And everybody might say, oh, design engineers, Bluetooth. Why on earth? Everybody knows what's going on in Bluetooth. That's not very destructive. You do destructive content for design engineers. And I'm going to say, just listen to Mohammed for 15 minutes and you might learn a thing or bits, novel bits. You might learn some novel bits about Bluetooth that you should learn and you should think about. So let's introduce you, Mohammed. First of all, tell us a little bit about NovelBits, just as a little bit of background. And then we can then talk about the things that you see going on in Bluetooth and why our community, of course, they may know a lot of it and they'll go, oh, I don't need to know about that. I can move on. Or they might know, oh, this Mohammed fella, he knows what he's talking about. So first of all, tell us a little bit about NovelBits and then we can go from there.
Yeah, thanks, Guy. I appreciate you having me on the podcast and the show. A big fan of your content and videos. So I
That's very nice
started
of you to say.
NovelBits. Yeah, thanks. I started NovelBits back in 2015, so it's been almost 10 years in July. It, I had worked at different companies before as an embedded software engineer, and I switched a lot of jobs. And in the end, I was like, there's something still missing, and I need to start my own thing. Now, I didn't know what I was going to do in the beginning, but my last few projects at my last full-time job were involved with Bluetooth, and it was on door locks. So being able to control door locks from your phone over Bluetooth Low Energy, technology called Bluetooth Low Energy. We'll talk about the differences between Bluetooth Low Energy and Bluetooth Classic, or what we usually use for audio streaming in the cars or for headsets and so on. But I started doing some contracting work, and then I did kind of an extensive kind of interview or customer development process with people on LinkedIn who were involved in the space. And the recurring theme from I think about 75 people who I interviewed was that there's a lack of education and training content for people getting started with Bluetooth technology on embedded devices, and also keeping up with the latest in the technology, because it really keeps evolving. We have maybe one or two releases every 2 years, so it really rapidly changes, and there's a lot of new features that get introduced in the technology. So I decided to focus on that. I started a website, a blog, and started posting about my just helping others learn about Bluetooth in general and as a basic foundation, but also kind of sharing what I'm learning along the way from Bluetooth, but specifically focusing on taking what's in theory and in the specs. The Bluetooth spec right now is over 3,200 pages. So you can imagine how complicated it is, and taking what that involves and what it entails in terms of how Bluetooth Low Energy works, and making it more practical. How do you apply these concepts into actual development boards, and in the end into actual products that you can release into the market? So that became my focus, is taking these complex situations, complex concepts that are in the spec, translating them into more easy to understand material and content, and helping engineers be able to embed and implement Bluetooth Low Energy into their Bluetooth connected products. So it's been about 10 years. I've changed a lot of things over the years, learned a lot from my processes and strategy and all that. Eventually, now I focus primarily on training companies and teams at companies who are involved with developing Bluetooth connected products. But I also help chip vendors and module makers with their technical marketing and expanding their reach into new audiences for their own platforms.
Right. So in terms of, I'm still struggling with the 32,000,
3,200, yeah, 3,200
32
pages or so.
3,200 pages of spec for Bluetooth. That's a lot of
Yep.
pages. It's a lot of pages.
Yeah.
So what you're describing there is that you're servicing both sides of this infrastructure. You're servicing both the chip vendors whose chips are going into systems, and then they're having to deploy, or their customers are deploying Bluetooth and understanding how those systems are communicating outside using Bluetooth. And then you're also talking to the OEMs who are using those systems, and then they're having to work out.
Correct.
And what you're saying there is that on both sides of those, you think that with a technology like Bluetooth, even with its 3,200 pages of specs, you think, oh, people know about Bluetooth now. Really, there's not a lot to know. All I have to do is just plug it in and off I go. And what you're saying is on both
Yeah.
sides of that, they're all still struggling to keep up with the modern world and understand all the implications and changes and how systems communicate with one another. So
Yeah.
how we ended up meeting for the sake of this discussion is you produce papers and you produce statements of things that you're learning as you go along. So the whole point of this podcast was to say, okay, we want to help you understand what's going on in the Bluetooth world. We want to help you understand the things that maybe you should think about. So let's have a chat with Muhammad. So do you want to just give us if you wanted to outline the world that you see from both the vendor and from the OEM, what are the things, what are the trends, what are the things that you go, right, these are things that are definitely going on now. These are the things you should be thinking about. And these are the subtleties and nuances in Bluetooth that you may not have thought about and you should be aware of. Over to you, Muhammad.
Yeah, so I'll talk specifically from an engineer's perspective because that's my background and that's the audience that I serve. So I kind of
And us.
like to
And us.
always, and so I like to think from that perspective because that's really where my content would, where I see my content helping. So from an engineer's perspective, a lot of products these days are getting connected somehow, or you need to add some connectivity. We all know the term IoT or Internet of Things, and it's been around for a few years. Went through some cycles of hype and so on, but it still exists these days, and it's even more so than before. And so people look for a technology that can connect their devices to other devices, and primarily smartphones. And Bluetooth is one of those technologies that have been in smartphones for a long time, and it's probably the only low power technology that exists in phones as of right now. There are other technologies that are getting introduced, but the majority of phones have Bluetooth in them. And when I talk about Bluetooth, there is a kind of a distinction between what's called Bluetooth Low Energy, sometimes people call it BLE, versus Bluetooth Classic, or what we usually use for streaming audio. So the original Bluetooth and that one that still exists to this day in your car when you connect your phone to your infotainment system in the car and you want to listen to music or even answer phone calls, that's all using Bluetooth Classic as of today. In the future, that will change though. Now
Okay.
we have that is devices are connected all the time, so the device that you have is always with the radio on, so it consumes a lot of power. So in 2010, the Bluetooth SIG, which is the special interest group, that's the group behind the standard that manages owns the brand name of Bluetooth and manages the specs and all that. They decided, the working group, who are from different companies who are members of the Bluetooth SIG, came together and they decided that they needed a new type of Bluetooth that would serve battery operated devices, or devices that need to run on batteries for longer periods of time. We're talking months or even years in some cases. So they had to come up with a new standard, and that's what's called Bluetooth Low Energy. And it simplifies some things and became a lot more flexible, easier to work for developers. But it gives you a lot of knobs, and you can tune in order to cater to your specific application. And the major use case for that is battery powered devices and battery life and low power consumption. But that opened up a lot of spaces and use cases for that. And so people started adding Bluetooth Low Energy into very small devices like medical devices that helped, take the responsibility of being able to view data or whatever to the smartphone, and then they could make the devices smaller by having that wireless connection to the phone and delegate all the UI related aspects to the phone, and so they could get the devices cheaper, smaller, reduced power consumption, not just by the radio or using the radio, but also by maybe removing screens from these devices so that you just
Yeah.
rely on the smartphone in order to access that.
So all the processing was being done on the smartphone as opposed to on the device itself, so therefore it'd be using less power, essentially.
Yeah, and when you remove a display, uses a lot of power. So if you can go away with a display on a device, then you're actually reducing the cost of the device, but as well as reducing the power and extending the battery life. So Apple was the first to introduce. So Bluetooth Classic was already in phones since the beginning, I think since 2000 or 2001. But in 2010, after Bluetooth Low Energy was released, it was still not yet in phones. I think in 2011, the iPhone 4S was the first smartphone to include Bluetooth Low Energy alongside Bluetooth Classic. And there's a lot of these chips are nowadays are dual mode, so they actually can operate in Bluetooth Low Energy and Bluetooth Classic. Those are meant mostly for phones or sometimes for speakers or for large devices that have battery. In low power IoT devices, you'll see most commonly a Bluetooth Low Energy only chipset that's included in there. But when Apple introduced that, they kind of opened up the space for wearables, for smartwatches, for medical devices to be connected to the phone over Bluetooth Low Energy. And because Bluetooth Low Energy is very focused on minimizing the power consumption, that really helped advance that space and allow people to create new use cases and new devices that could leverage that technology and enhance the user experience. So when going back to the beginning where an engineer maybe wants to connect their device, if a smartphone is meant to connect to their device and interface with it wirelessly, Bluetooth Low Energy is probably the main technology that they would go to and implement into their products. The problem is in a lot of cases there's a lack of know-how and there's differences among different chip vendors on how you implement that. So that's where my focus is kind of to take things, simplify them from the spec, but also make them more practical and more applicable in the actual product development aspect of things.
So let's just get back to that then. Let's just get. I know. I'm going to go back to this 3,200 pages or whatever it is. Doesn't matter. That's a spec. So what you're just describing, you're giving us a lovely background about how this all happened. It all happened around the Apple iPhone, and you had low power Bluetooth, and you had Bluetooth Classic, which sounds like Coca-Cola Classic and whatever. And then you're saying right, and then we got into these devices where batteries was important. We started moving all the processing to the devices, and that introduced us into this whole new world where you could get data from the device onto the phone or whatever the interaction was. And use that example of the door being your first example as a young design engineer trying to work that out. Why don't people just stick to the specs?
Well, I mean, they have to stick with the specs. The problem is understanding the specs and
Right. So
translating
what's the
that
problem
into,
there? Help
yeah,
the listeners, the watchers, understand what the translation from the specs. It's all written down. Just follow the
yep,
rules. Everybody will be compliant. Everybody will know what we're doing. And then you're saying, oh, it doesn't quite work like that.
yeah.
So today, you're this highly experienced consultant, probably knows more about Bluetooth and Bluetooth Classic and low power Bluetooth. Explain why there is that problem with interpretation of the specs,
Yeah.
and then the problems that you see every day that have to be solved.
Yeah, so there are quite a few reasons there. First of all, the spec is very long and very heavy with technical jargon. And if you're looking at a junior engineer or somebody who's just getting started, they're not going to go open a PDF that's 3,200 pages long and start reading through it. The other issue there is, yeah,
Nobody's read a user manual for 15 years. They're not going to start doing it now,
right,
are they? Let's be honest. Okay, it's on
exactly.
YouTube.
Yeah. So there's that part, but you also have the spec is actually for both Bluetooth Classic and low energy. So the core spec is for both, and they're kind of mixed together, intermingled there. So sometimes it's even hard to find, even for me, sometimes hard to find what's for LE, what's for Classic. So that's one aspect of it. The just how lengthy it is, how technical it can be, and how complex it can be. Also, the people who work on the specs are not necessarily product developers or product, they work on actual products. So they might have some thoughts about how to word something or how to explain something or how to lay it out that maybe an engineer would not understand how to actually apply that. Now, the chip vendors, like different chip vendors who provide development kits for Bluetooth Low Energy, development, they do provide some level of education and training, but it's very focused on their own SDKs. So you can take any example there, and you'll see that you'll find documentation for how to use the SDK to perform certain actions, for example, to scan for a device, to advertise as a device that gets discovered by the scanner, how the connection gets established, all these APIs and functions. And they can only go so far in terms of explaining how Bluetooth actually works, and keeping up with the latest features that are involved. So sometimes it's and that differs, even the APIs and the SDKs differ from one vendor to the other. So there's also that gap. If you have somebody who's always worked with a certain vendor and they go to work with a new board, a new chip from another vendor, then they can run into that issue where the APIs don't translate one-to-one. Now I need to understand how the SDK. So there's a lot of things going on in the engineer's mind in order to understand, and put on top of that, you put the issue of learning about a new technology that maybe they're not familiar with from before. So there's the aspect of that. You also have some level of, I guess, education on things, because the spec is written for people who implement stacks, not necessarily for people who implement or develop products. So it's written for the people who work on the software stack that runs on the chipsets. So at the chip companies, you'll find that people are already experts with Bluetooth, and they know because they actually implement these on their chipsets and they provide them for developers.
So do you think at some point there's going to be this muddied water and the specs were written to not take that into account? So is
Well,
there just quickly,
yeah.
is there an argument to suggest that these need updating?
Well, the specs are being updated every 1 to 2
Yeah,
years, and
but it's like layering layers of code onto layers of code, isn't it? It's not backdating. It's not
yeah,
taking away stuff that's
sometimes it
already
gets
there.
improved. Sometimes there are improvements to the existing, specs and the language and the graphs or whatever tables that are included. But it's still, it gets too complicated to be able to go back and update certain things. But it's also the spec only lays out it's a specification, so it only lays out the rules, the
Yeah,
the the
the
things
ingredients.
that need to, that need to be defined. But then when you look at a higher level, from an application level, you don't know how to put things together, and so you have to piece some things together. You have to also come up with certain solutions based on the spec or based on understanding how Bluetooth works for your own specific application. So sometimes, and because of how flexible Bluetooth Low Energy is, there's just so many ways to use it in different devices. So that's where kind of there's a gap between what's in the spec, what's in documentation usually, and what goes on in actual products that get deployed in the field.
Okay, so you're interacting every day. You have a good knowledge base with the silicon vendors, who we probably know who they are. But who are the top five now? Just for instance, just say now who they are in your
Yeah, I
experience.
mean, from my experience in the Bluetooth space, Bluetooth Low Energy specifically, not
Yeah.
classic, it's Nordic Semiconductor, Silicon Labs, you have Infineon, Renesas, um, trying to think what else. There's Qualcomm, obviously, for dual mode, where you have in phones. I mean, there's quite a few. Those are just the ones that came to my mind.
So they're sitting there with their own. They've absolutely followed the specs. Their
Hmm.
chips are ready to go. They then create their SDKs, which is the interaction that gives the developer the environment where they
Correct.
can then interact with their environment, which stick to the specs. But at some point, they have to have their own. The bit in the middle where the developer interacts is that SDK environment.
Hmm.
Um, are is do how does the design engineer then go about saying has the design engineer got to truly understand what the spec they want and then choose their vendor, or do they choose their vendor and then go work around that SDK? What in your opinion, just so we can get right down to the detail of this, we'll get right
Yeah.
down to so we bring value on this video. We want to get right down to the granular detail of, you've explained very nicely the background. You explained very nicely that there's these two sides. They have to meet in the middle, and there's confusion in that middle, which is nobody's fault. It's just how it is. But at some point, what we want to get out of this video is some value to help people work out, why is there that confusion and what do I do about it? So can you help them watching this
Yeah.
understand how you unpick that conundrum?
Yeah, so I mean, the best way for a new person to get started is always to look at example applications that are already included in the SDK. So the vendors will provide example applications for different use cases. The thing is, they can only provide so much, but then you
But won't
also
they
have
all?
different.
But won't they all necessarily? Well, I mean, basically, they'll all have the same, won't they? They'll all. I mean, I've never unravelled one of these, but won't they? They'll all have, door
Well, they're very
opening.
specific. They're very specific to their SDK. So if you're starting with a new SDK, a new chipset, then you want to learn how to do certain things, and that's where you can get started with example applications that are provided by the chip vendor. The thing is, there's a lot of things that go into optimization of throughput, data throughput and transfer, optimization of power consumption, optimization of range, how long you can communicate between devices. All of these are not laid out in the spec. They give you the
Right.
parameters and the rules and the limits to what you can do, but then it's up to you as a design engineer to come up with the solution that is most relevant to your use case and to your application.
Right.
And the vendor might have some examples that cover certain cases, but in the end, everything is going to be very specific to your use case and your application.
Okay. So if you're a design engineer, you know that you're going to be going to these vendors. Um, if you were sort of building some sort of spreadsheet, you're going to then build out and say, right, I need to choose the right SDK, the right chip vendor with the right
Hmm.
SDK. They're going to give me applications that are going to help me understand. So if you were going to go through today, every time you go and somebody says to you, help me understand how I'm going to implement BLE today,
Hmm.
you say, right, here are let's just go through the
Yeah.
Mohammed's
Okay.
top five, top 6 or 7 things that you're absolutely going to have to take into consideration because what hopefully I think what we're getting out of this is, if you follow Mohammed's rules, it's going to be obvious because you're not biased anyway. You've made absolutely clear there's 5, 6, 7, and there will be more, but of
Hmm.
chip vendors. All of them are excellent companies, but all of them still have this middle ground. All of them still have this middle ground, which is their SDK. So you're gonna at some point gonna have to bring that in and say, right, which one's best for me here? So what a if Moham's going to sit down with you and go, right, well, we've got to start at the beginning. What would be your recommendations as to how you go through the things that you're going to ask yourself in order to choose the right vendor for the other side?
Right. Yeah. I mean, there are a few factors. So with Bluetooth, there are some, I guess, hard requirements that have to be implemented in every BLE device. But then the specs, because of the advancement of the specs and the new features, a lot of them are optional. These new features that could help you in your application. So one of the things that you want to keep out for is to look at the different chipsets that are available from different vendors and figure out which features you actually need for your own application. So if you're developing something that has to be very low power, or so the low power aspect of it usually is going to be standard. But if you're looking for long range communication using BLE, then you have to look for a chip and a stack that supports what's called long range mode, for example. If you're
Okay.
looking for high data throughput, there are specific modes that are optional. They are supported with smartphones, but they're not necessarily supported with every SoC or a chipset that's out there. So you want to choose one that satisfies that and has that requirement. Obviously, every chip is going to be, different from a hardware perspective. So their power consumption levels and what they can do with their optimized hardware design, and also the stack, the SDKs that are provided, those will differ among the different vendors. So you have to keep that in mind. Some things will be documented in data sheets and so on, like how much uh, the current draw is for TX for transmitting versus receiving in sleep modes and so on and so forth. But in the end, if you can't really get everything from the data sheet, you will have to kind of implement something yourself and play around with it and do some measurements to figure out. The other thing that I would look for is definitely the SDK and the IDE that's supported by the chip vendor. So traditionally in the embedded space with microcontrollers, everything has been mostly like Eclipse-based IDEs. Eclipse is a framework for IDEs. An IDE is basically your environment that you write the code in and build the code and compile it and then flash it to your device, to your development kit for development and for testing. And so a lot of them traditionally have been provided to be Eclipse based, and then the chip vendor basically puts their own secret sauce on top of it, or just the customization to their own kind of liking, and provide that to the engineer. More recently, we've had the introduction of what's called the Zephyr real-time operating system. It's an open source project that allows you to build within Visual Studio Code, which is a free IDE that's available, and it's just an extension that you provide, the vendor would provide. For example, Nordic does this. They were kind of spearheading this movement, and that allows you to be a lot more flexible. You have more flexibility with the SDK. You also get access to a lot of third-party open source modules that are available for you to work with different hardware, accessories, or peripherals that you need in your device, as well as like being able to customize the stack down to removing all the features that maybe you don't need, and you can, that saves RAM, that saves money as well with the cost of the chipset that you would have to use because you don't use as much space. It also saves power and so on. So there's some of these factors. Another factor I would throw in as well is the support that you would get, the level of support that you would get from the vendor. So a lot of them have these online forums, but they vary slightly from one to another. Some of them are a lot more developer friendly in terms of they will serve individuals regardless of how many potential chips they're gonna use or build in their products, versus some of them are a little bit more focused on bigger customers. So you might find those differences among the vendors. Another one is the tools that are provided, like the SDK and the IDE. Some of them, the chip vendors will provide additional tools that are not necessarily just for building the code and flashing it, but also for debugging, for testing, additional tools that will help you achieve your job and achieve some of the things like lower power consumption, being able to measure the power, being able to optimize it, design with different parameters and so on. They will provide additional tools such as a smartphone application or even a desktop application that will help you achieve this. So you want to have more of a holistic view and not just go for the price of the chip or the power consumption or the current draw metrics that are provided in the data sheet. There's a lot that goes on into it, not just what's kind of apparent on paper. You want to study, again, the support is pretty big, because if you run into an issue and you can't get support for a few days, then you've lost a lot of time and money just trying to figure out what's going on. But if you can get support very quickly, then you can move on and go on to the next thing and develop your product and get it to market faster.
Yeah. With your experience of the chip vendors, would you say that in many respects they actually set out to be agnostic? So they're not setting out necessarily. So that means that you've really got to be from the OEM side. You've got to be quite strong with yourself to say what exactly is it that I want, because actually all these vendors are all trying to actually win every bit of business. So
right.
When I get into the nuance of it, which is that middle ground that we've been talking about, when I get into that, they actually do vary. So you've talked about power, you've talked about flexibility, you've talked about communities, you've talked about support, and all those sorts of. They have what we call in the modern world soft skills. They're not hardware. It's not about what the spec says.
Yes.
It's that middle stuff. So what you're
Right.
saying is actually, from a hardware point of view, you're not going to go wrong on hardware. They're all very good companies. They all do very good technology. But
Yeah.
for you, it won't be that any of them are wrong. It's just that for you, one of them will definitely fit the spec better in that middle ground, in that nuanced ground that's not about specs. And neither one will be wrong or the other. It's just that one will definitely be better in those soft skills
Yeah.
than
And
the others just because of your application.
yeah, and I mean, some of them do focus on specific industries more than others. And so you'll see that their chips will provide some additional functionality. Like security is becoming very important. So a lot of them will include additional features that, are they allow you to make your product more secure. So you can see that will cater more to medical device companies or to defense companies or somebody working on something that's highly, has to be very robust from a security point of view. So there are some specific vendors or vendors that cater to specific markets and specific verticals. So if you are in the vertical, you'll sometimes find that most of the in a specific vertical, you'll find that maybe one of the vendors are more common for that vertical, maybe because of their focus, because of their expertise that they've built over the years, and maybe because of their features that they're focusing on and providing and including in their chip and their solutions.
Yeah, yeah. Okay, good. I think that's been I think you've been very good. The history story at the beginning was very interesting, where I decided that it was all about Coca-Cola and Classic. But in actual fact,
Yeah,
that's all that all builds towards where we got to now, and I think that's actually really, really important. So what you've described there is, they're all great companies. They're all going to get. I want low power Bluetooth. Right. Okay. There's not just one. There's 5, 6, 7, maybe. They're all
yeah,
very good. But so what you see in the spec sheet is great. But what you're then saying is they'll have their own splits, like the security for medical devices. They might be a bit better at that, so that might be a bit of an obvious choice for you. But
hmm
actually, it's the soft skills in the middle that you've got to put a lot of attention to, because
yeah,
this is really important to you. Your side of it is really important. Your bit is really personal. So you've got to sort of look very carefully into that middle ground, that customer service, the nuance of the power, the
yeah.
community, the other things that won't be on the spec sheet for the chip, but they
Correct.
come with the kind of the culture of the company and what they offer in that middle ground. And so that's very interesting, because it's not about the chip
Absolutely. Yeah.
spec, because they're all brilliant, they're all excellent,
Yeah.
but they'll all have their own strengths in that middle ground, and that's where
Correct.
you should focus your efforts in choosing who your partner is for your
Yeah.
next project.
Absolutely. Yeah.
But yeah, very good, very good. Well, I would recommend. Mohammed produces a huge amount of documentation. He writes all about stuff on LinkedIn. It seems like every week, but it's probably every other week.
Yeah.
Time flies.
It
But you
depends.
seem,
Yeah.
yeah. But you so go and we'll put the link into the description, because we can do that now because we're YouTube partners. So we can put that in. You can go and find Mohammed on LinkedIn. You can follow him, which I would recommend, because he can tell you all sorts of new stuff. And in the next 6 months, maybe we can have an update or a discussion, or maybe even quicker than that. We can bring up something. We can take one of those subjects and dive a little bit
Yeah.
deeper into them, because that's an overall introduction about what you should think about when you're starting your next project that needs Bluetooth, and some of the nuance that you need to think about that you may not have considered when you look at these 3,200 pages of specs on Bluetooth, and all the hardware from the silicon vendors. So, Mohammed, you've been absolutely pleasure
Yeah.
to have on our chat today.
Yeah. Same
Thank you
here.
very much for your intellect, your experience, and your knowledge. And we will definitely have you
Appreciate
on
it.
again
Bye.
to help our community learn about Bluetooth.
Awesome. Thank you.